Greetings, it's Mr. Porter again, and we're continuing our series on Pascal's triangle. And we've already discussed what Pascal's triangle is, which is simply a series of numbers in a specific order that runs to infinity. We've also discussed binomial expansions and how the Pascal's triangle and binomial expansions are interrelated. Well, here's another idea that shows the interrelatability of Pascal's triangle with some other dynamics. Here we have a word problem that's focused on probability and flipping of a coin. I'll read the problem. If you flip a coin 5 times, what is the probability that exactly 2 heads will occur? This word exactly is rather significant. It means exactly and only 2, not more than 2 and not less than 2, specifically only 2 heads. So what I'll do first is take advantage of the idea of the tree diagram so that we can get a visual representation of what this looks like, because what we don't want to do is simply guess at this problem. So let's work out the visual massage of what this looks like. For my visual tree diagram, I'll start with myself or you, and I'm flipping a coin. If I were to flip a coin, there's only 2 options, which means I'm going to have a heads as one option, and I'm going to have a tails as the second option. And this I will identify as flip number 1. And I will label it so that it's easy for us to keep up with. This is flip number 1. Then from here, we'll have the next flip, which will be another set of 2 options. Only heads, or it'll come up as tails. Same for this branch. If I had landed with tails first and I flip it again, I have either heads or I have tails. This will be flip number 2. And we need to continue because we need to have 5 flips. So from here, I have option either a heads or I have a tails. Here, I have either a heads or I can result at tails. In like manner, heads or tails. And finally, for this option, it could be either heads or it could be tails. This is flip number 3. And this requires us to go 2 more flips, which heads here or tails. And I'm sure that you all have done this before. So producing a tree diagram is not problematic for you. Heads, tails. What you may not like is what you see that I have going on here is that the diagram gets extremely busy very quickly. If you don't have a method for keeping things orderly, it is very easy to confuse the situation by either running out of space or writing items on top of each other, like I'm beginning to do here. Heads, tails, and lastly, heads, tails. And this is flip number 4. Let's make sure we label that flip number 4. Last, I have flip number 5. Let's see how creative we can be here with our spacing. Heads or tails. Heads or tails. heads or tails, heads or tails, heads or tails, heads or tails. Notice now I've got to make more of a slant to make sure I get everything in so that you all can see. Heads or tails, heads or tails, heads or tails, heads or tails. Quickly running out of space. Heads or tails. And we have 1, 2, 3, 4, 5 more to do, and I'm going to bring those over here. Heads or tails. Heads or tails. Heads or tails. Heads or tails. And then my last. Heads or tails. Now, this is the tree diagram that represents this problem. So all we've done thus far is focus on nothing more than this first part. If you flip a coin 5 times, this tree diagram represents all the different options that are available. Now, I'm going to walk through a couple of ideas here in terms of figuring out what does it mean that it only has exactly 2 heads. Well, what that means is I need to also label this as flip number 5. So this entire piece here will be flip number 5. And this one I'll label up here. Take advantage of space. All right, so first I only have exactly 2 heads. That means from flip 1 all the way through to flip 5, when we connect the chain together, all the pieces, we can only have 2 heads. So here's a link or a chain that would not work. Here's a grouping that would not work for this problem. If you were flipping a coin and you got heads on the first flip, you then flip the same coin and got heads on the second flip, you then flip the same coin and got heads on the third, that tells you immediately that this chain of events does not qualify for this problem because we've already gotten one head, and another head, which is 3 heads. We can only have exactly 2 heads. So that pathway does not work for this problem. Here's a pathway that would. I could have a heads on the first, I could have a heads on the second, and then all the rest of my flips would be tails. All the rest of my flips would be tails. I have 5 elements in my chain, flip 1, flip 2, flip 3, flip 4, flip 5, but inside that entire sequence of events, of flips, I only have 2 heads. That's one option that works. Here's another option that works. I can have a flip of heads on the first, tails on the second. I'll change colors here. I can have tails, heads on the first, tails on the second, tails on the third, tails on the fourth, and then I can get to a heads on the 5th. That means in my sequence of 5 flips, flip 1, flip 2, flip 3, flip 4, flip 5, I have a heads, tails, 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 heads. I only have 2 heads, which exactly identifies and matches the requirement here. Because we've gotten very busy with our tree diagram, I'll let you know that there are exactly 10 options. There are 10 ways to achieve 5 flips and getting only 2 heads. There's only 10 options. And we'll discuss why that's significant in our next series. Thank you for your time.